Welcome to Homework Lib.
In this question, we have been told that two identical strings making an angle of 30.3 degrees with respect to the vertical support a block of mass 16.7 kg. We need to find out the tension in each of the strings. So first of all, we need to draw a free body diagram of all the forces acting on the system. So first of all, we know that the weight of the block is going to act vertically downwards, and that is going to be W. Now tension in this spring, we'll call this tension T. It is going to act along the string, that is going to be, and tension in the second string, it's also going to be the same because they both are identical strings and they both make the same angle with the vertical, which means that the tension in both of them is going to be equal. Now as you can see, the tension T in both the strings act at an angle, which means we can divide it into or resolve it into horizontal and vertical components. So for this case, the horizontal component of T is going to be T sine theta. The vertical component is going to be T cos theta, and the same for the other string. This is going to be T sine theta, and this is going to be another T cos theta. So there are two forces we can represent it with, or we can draw a simplified free body diagram. So representing this knot, we are going to draw another free body diagram. So at this knot, the weight is acting downwards, W, T sine theta, and T cos theta. The same with the other string, T cos theta and T sine theta. Now we know that this system is in equilibrium because it is at rest. So we need to find out the tension T in the string. We need to find out the value of T. So we are going to write down the equations of equilibrium. So the sum of all the forces in vertical direction must be 0, and sum of all forces in horizontal direction must also be 0. So if you look at horizontal direction, T sine theta is acting toward the right. So we are going to use the convention that right side is positive and upwards is positive. Right and upwards is positive, down and left is negative. So plus T sine theta and minus T sine theta. This is going to be equal to 0. So they both are the same, so they are going to cancel each other out. So 0 equals to 0. So this satisfies the equation. Now for the other equation, sum of vertical forces. So there are two forces acting upwards, T cos theta plus T cos theta plus T cos theta, and the weight is acting downwards, minus W. This is going to be equal to 0. So 2T cos theta is going to be equal to the weight. Now we need to find out the value of T. So T is going to be weight divided by 2 cos theta. Now we can apply the values. We know that weight is going to be equal to mass into gravitational acceleration. So mg divided by 2 cos theta. If we put down the values, the mass of the block is 16.7 kg multiplied by the gravitational acceleration, which is 9.8 meter per second square, divided by 2 cos theta is 30.3. This will give us the value of the tension in the string, that is 94.8 Newton. So that is the answer for this question. The tension in each of the string is 94.8. Because the tension in both of the strings is going to be the same, so the value of T is 94.8 Newton. I did not represent.